Okay, Wildcats, today we're going to on page 23, linear inequalities in two variables. Steps to graph systems of inequalities. Step 1, put the inequality in slope-intercept form. A special note, when you multiply or divide the inequality by a negative number, the inequality symbol flips. Step 2, identify the line, type, and shading. Y is less than mx plus b is a dashed line and shaded below. Y is less than or equal to mx plus b is a solid line and shaded below. Y is greater than mx plus b is a dashed line and shaded above. Y greater than or equal to mx plus b is a solid line and shaded above. Step 3, the solution is on the solid line or in the shaded region. All right, let's look at the first example. All right, in order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below the line, and if the boundary line is included in the solution. All right, now we're going to do this without a calculator, but if you have any questions about how to graph this on the calculator or Desmos, please ask me in class, okay? So what we're going to do is we're going to subtract 40 from both sides. 40 minus 40 is 0. You get 5y greater than or equal to 1x minus 40. Okay? Last step is we're going to divide everything by 5. 5 divided by 5 is 1. So you get y equals 1 divided by 5x minus 40 divided by 5 is 8. Okay? The boundary line is given by the function y equals 1/5 x minus 8. The graph is shaded above the line, and the boundary line is included in the solution. All right, let's take a look at. If you give me a few seconds, the sun seems to be making things bright, so I'm going to adjust the lighting real quick, and we'll get started on example 2. All right. In order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below or the line, and if the boundary line is included in the solution. All right, so first thing we do is solve for y. So we're going to add 1/4 to both sides. Well, negative 1/4 and 1/4 is 0. You get y less than or equal to 7x plus 1/4. Okay, the boundary line is given by the function y equals 7x plus 1/4. The graph is shaded below the line, and the boundary line is included in the solution. Let's take a look at the next example. All right, example 3. In order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below the line, the boundary line is included in the solution. So we need to solve for y, so we're going to multiply. We only need to get y by itself, so we're just going to multiply everything by negative 2. Okay, negative 2 times negative 1 is a positive 2y divided by 2. Now, you're multiplying by negative, so the inequality was here. Now it's going to flip and be here. Negative 2 times negative 3 is a positive 6x divided by 4. And then negative 2 times negative 7 is minus 14 divided by 8. Well, 2 divided by 2 is 1. So you get y greater than or equal to 6 divided by 4x. Well, wait a second. 6 divided by 4 reduces to be 3 divided by 2x. And then 14 divided by 8 reduces to be minus 7/4. Okay. The boundary line is given by the function y equals 3/2 x minus 7/4. The graph is shaded above the line, and the boundary line is included in the solution. All right, let's look at the next example. All right. In order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below line, and if the boundary line is included in the solution. So the first thing we need to solve for y, and then this one, all we need to do, well, first off, we want to put y on the left side. So we're going to put y plus 7. Now, technically, the inequality is pointing to the y. So I didn't flip it. I'm just rewriting this so it's correct. And I'll prove it to you if I just flip the paper over. Technically, that is y less than, okay? So we have y, I'm rewriting y plus 7 less than negative 5/3 x, which these are equivalent. These are the same thing. I haven't flipped any inequalities, okay? So now, solve for y. I'm going to subtract 7 from both sides. 7 minus 7 is 0. You get y less than or equal to negative 5/3 x minus 7. Okay, the boundary line is given by the function y equals negative 5/3 x minus 7. The graph is shaded below the line, and the boundary line is included in the solution. All right, let's take a look at the example. All right, excuse me. Select the graph of the inequality. So before we can select it, we have to solve this for y. So we're going to subtract 3x from both sides. Okay, 3x minus 3x is 0. You get negative 3y greater than or equal to negative 3x plus 21. Now we're going to divide everything by negative 3. Now remember, when you multiply or divide by negative, the inequality flips. So this becomes 1. You get y. This was greater than. Now it's less than or equal to. That's 1x minus 7. Now remember the number in front of x is always a fraction, so we're going to divide that by 1. And now let's graph. So first off, the y-intercept is negative 7. So we're going to look at, first of all, the y-intercept is negative 7. That's correct in A. Now, this is a solid line. All the lines are solid, so that's okay. Next, this does not have a y-intercept at negative 7, so we can mark out B. Okay. This does have a y-intercept at negative 7, so that's okay. And this does not have a y-intercept at negative 7, so it's not D. Okay. And let me just, so we're clear on what the x and y axis. This is the y axis, which means that's the y-intercept. And this is the x-axis. Okay, same thing here. Y-axis, so y-intercept, x-axis, y-axis, x-axis, and y-axis, x-axis. Okay. Now the slope, well, first off, the shading is below. So we can mark out A because the shading is above. Okay, so we're looking at C. Well, the answer should be C, but let's verify the slope. The slope is up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So the slope checks out. The shading and y-intercept, so the answer is C. All right, let's move on to the next example. All right, select the graph of the inequality. Before we can select the graph, we need to solve this for y. So we're going to subtract 3x from both sides. That's 0. You get 2y less than or equal to negative 3x plus 18. We're going to divide everything by 2. That becomes 1. You get y less than or equal to, notice I didn't flip the inequality because we didn't divide or multiply by negative 1. That's negative 3 divided by 2x plus 9. Okay, now let's graph the y-intercept, but before that, let's highlight the x and y axis. All right, so let's first check for the y-intercept of 9. So that does not have a y-intercept of 9, so you can mark out A. This does have a y-intercept of 9, so we're good there. This is good, y-intercept of 9, and y-intercept of 9. So these are okay on the y-intercept. This is a solid line. They're all solid lines. So now we know we're shading below. So this is not below, so we can mark out C. This is below, so we're okay. So now let's check the slope. Negative 3, so down 3 to the right 2. So down 1, 2, 3 to the right 2. Down 1, 1, 2, 3 to the right 2. This slope checks out. So far the answer is B, but let's check D. Down 1, 2, 3 to the right 2. That is not correct, so the answer is not D. The answer is B. All right, let's take a look at the next example. All right, select the graph inequality. So first off, let me highlight the X and Y axis. All right, now that's a solid line, so these are all solid lines, so we're okay there. All right, now y is less than or equal to 5 is a horizontal line. Okay, so we know it's not 8 because this is vertical, so this is actually x less than or equal to 5, so we can mark out A. And we can also mark out C because this is x greater than or equal to 5 because it's a vertical line. Okay, so we're looking for y is less than or equal to 5, so the answer is D. Because this is y greater than or equal to 5, so it's not B. All right. So go and finish up example 7. All right, let's look at example 9. In order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below the line, if the boundary line is included in the solution. So we need to solve for y first. We're going to subtract 12 from both sides. So 12 minus 12 is 0. You get 2y greater than 1x minus 12. We're going to divide everything by 2. 2 divided by 2 is 1. You get y greater than 1/2 x minus 6. So the boundary line is given by the function y equals 1/2 x minus 6. The graph is shaded above the line, and the boundary line is not included in the solution. All right, let's take a look at example 11. In order to graph the inequality using a graphing calculator, tell whether the function to enter for the boundary line, whether the graph should be shaded above or below the line, the boundary line is included in the solution. So again, we need to solve for y, so we're going to subtract 24x from both sides. That becomes 0. You get 30y less than negative 24x plus 180. Okay, we're going to divide everything by 30. 30 divided by 30 is 1. You get y less than negative 24 divided by 30 reduced to be negative 4/5 x. And then 180 divided by 30 is plus 6. The boundary line is given by the function y equals negative 4/5 x plus 6. The graph is shaded below the line, and the boundary line is not included in the solution. All right, let's take a look at the next example. All right, select the graph of the inequality. So before we can do that, we need to solve for y. So we're going to divide everything by negative 16. Now, that divides and becomes 1. When you divide by negative, this was greater than, now it's less than. Negative 48 divided by negative 16 is 3x. We're going to divide that by 1. And then negative 80 divided by negative 16 is let me think. 5 plus 5. Okay, so now this is a dashed line, so they all are dashed lines, so we're okay there. it's less than, so it's shaded below. So that's shaded below, that's shaded below. Looks like this is not D because that's shaded above. Okay. Now we're going to find the y-intercept of 5. So we look okay here at 5. It looks okay at 5 right here. This is at 5. And see, yep, that wasn't at 5, so we can eliminate from there as well. All right, so now the slope is up 3 to the right 1. So let's pick a point. This one looks good, so we're going to go up 1, 2, 3 to the right 1. So this is okay so far. Up 1, 2, 3 to the right 1. So that's okay. So now let's look at here. So I'm going to go up 1, 2, 3 to the right 1. It's not B. Now let's go here. We're going to go pick a good point to start with. Go up 1, 2, 3 to the right 1. So it's not C. So the answer has to be A. All right. Let's look at the next example. All right. Enter a linear inequality to represent the graph given. Okay. So first off, we already know the inequality because it's a solid line and shaded below. So we know it's y less than or equal to. Okay. So we need to put it in slope intercept form. I equals mx plus b. Okay. So we need to find the slope. The slope equals, we subtract the y value. So, and actually let me use the formula y2 minus y1 divided by x2 minus x1. Where this is x1, y1, this is x2, y2. Okay, so that's negative 5 minus 0 divided by 0 minus negative 12.5. Okay, well then you get negative 5 divided by, negative times negative is a positive, so that's plus 12.5. Okay, so your slope is negative 5 divided by 12.5 x plus, now we need to find the y-intercept. Well, it crosses at 0, negative 5, so that's minus 5. All right. So let's take a look at the next example, or last example. All right. So this shaded below, so we know it's y, but it's less than because it's a dash line, so no line underneath, okay? So we need to find y less than mx plus b, okay? So to find slope, we know it's y2 minus y1 divided by x2 minus x1, where this is x1, y1, this is x2, y2, okay? So then y2 is negative 6 minus 6 divided by 2 minus negative 2. Well, negative 6 minus 6 is negative 12. Subtracting negative becomes positive. 2 plus 2 is 4. Negative 12 divided by 4 reduces to being negative 3. Okay, so that's negative 3x. Now we need to find the y-intercept. Okay, and so let me highlight the axis. So this is our, so we can see that the y-intercept crosses at when y is 0, so plus 0. My guess is Alex is going to ask you just to write negative 3x. All right, go and finish up your examples and start working on your assignment and have a wonderful Wildcat day.